we have seen what is the second law of thermodynamics, and we have established, we have seen the two statements of second law of thermodynamics, and we have established the equivalence of these two statements. Now we will try to see what is a reversible process. See, what is the concept of a reversible process? A reversible process is defined as a process that can be reversed, okay, that can be reversed without leaving any trace in the surroundings. Okay, so that means you can see here a process and it moves from state A to state B. So it comes back to its initial state A. So that means this can be reversed. So this process is reversed. But when will it become a reversible process? This will become a reversible process because uh, so this is possible only if the net heat and net work exchange between the system and surroundings is zero for the combined process. Okay, if you combine these two processes, that means the net heat and work exchange should be zero. So you can see that QAB plus WAB plus QBA plus WBA is equal to 0. So that means whatever heat that is exchanged during this process AB, that is QAB, and you may have a work exchange that is in AB, W, and so the heat exchange in BA is QBA, and here it is WBA. If you sum all these up, you will get 0. That means if you are releasing here QAB, so in this process it should absorb that QAB. Okay, if you are producing work here, you need to supply work here. Okay, like that. So the sum of all these should be 0. So this is what you mean by a reversible process. This is a very important concept in second law of thermodynamics. So we will see why. So see one more, we will see an example of another reversible process. No, for a process, you can see that this is a Pepsi can. It takes a see when it is cool, when it is kept outside the refrigerator, it will get cooled. It gets cold because it takes in heat Q from the surroundings. Okay, so this is a process. So the Pepsi can initially the temperature may be some 10 degrees Celsius. Finally, it will reach the room temperature, that is 25 degrees or 30 degrees Celsius. So that is a process. So that is a system that changes its state from one state to another through a process. So when can you call it a reversible process? So this can be called a reversible process if you can take this heat outside from the Pepsi can. Okay, so if you take this heat out, again the temperature can be decreased from this maybe room temperature to initially it was at 10 degrees Celsius, then you have some 30, find 30 to 10, you can bring back to its original temperature by taking out heat. Okay, but in order to take this heat out, okay, from the Pepsi can, you need to keep that in a refrigerator, right? So in a refrigerator, you need to supply a work in the compressor, and this will reject a heat that is Q plus W to the atmosphere. So you can see that through one process, the first process, the Pepsi can changes its state from 10 degrees Celsius to 30 degrees Celsius by taking in heat. Okay, it is possible to reverse it from 30 degrees Celsius to 10 degrees Celsius. Okay, by rejecting this heat. Okay, but to reject this heat, you need a refrigerator which needs a work W, and it will release a heat Q plus W. So what is a net change in surroundings here? So initially it takes in heat and then it rejects heat, that is Q plus W. Okay, so this will get cancelled, but this W, this heat energy is supplied to the atmosphere. That means that will leave a trace in the surroundings. So there is a change in the surroundings. Okay, if this W is 0, then you can call this process a reversible process because you are taking in heat and then you are supplying back that heat to the atmosphere. So there is no change, trace in the surroundings. But This is not possible. Why? Because if W is 0, that means this violates closure statement. So it is impossible to transfer heat from a low temperature body to a high temperature body without an external work, because it violates closure statement or second law of thermodynamics. So this is not an example of a reversible process, and this is why it is very difficult to achieve reversible process. It is impossible to achieve a reversible process in real life. But still we study reversible process. We will see why. We will discuss some more examples.